Hello, everyone. Thanks for being here. It's actually pretty cool because Sunday talks are a bit of a catch-22. Uh, because on one hand, we are not jet-lagged anymore, which is great. On the other hand, we're all exhausted from all the hacking and partying that's been going on these days, which is terrible. But still, I'm very, very happy to be here and to see so many of you. This talk is Smart Devices Dumb Resets, and it'll be a fairly short session about some of my experiments with various retailers and how they approach resetting devices before reselling them as repackaged, pre-owned, or whatever other term they use for labeling stuff that's been, well, used and returned. The ones that really, really makes me giggle is pre-loved. And I really hope that whoever used my robot vacuum before me didn't use it for love. Okay, just a quick disclaimer. In this talk, I'll not mention any retailers. My aim here is not to point fingers, but to inform and to entertain. So any information which may indicate a potential retailer or vendor is purely coincidental and only used to make a point. So before we jump into the fun stuff, let me introduce myself. I am Matei Anthony Josephs, a senior penetration tester at Happening XYZ, where I work with a really cool team of hackers. I'm a junior husband, or does 3 years of marriage promote me to mid-level? I don't know. Anyway, I'm also the founder of HiveHack, a boutique cybersecurity company built alongside my wife. And generally speaking, I just love hacking stuff. Websites, people, devices, pretty much everything. And I'm not a hardware hacking expert whatsoever, but I enjoy the potential impact of IoT hacking. The idea that actions done in a virtual environment can have an impact in the physical environment fascinates me to this day. So I remember how one time I was at a conference and found that the self-service check-in tablets were not properly configured. I escaped the kiosk mode pretty easily and went on to discover that the tablet was running Windows. So I found the Wi-Fi password and connected my own device to the network. And after a quick network scan, I found several devices with HTTP and HTTPS ports open. And guess what those were? Those were the badge printers. But they were password protected, so there was nothing I could do about it, right? Well, yep, that's wrong. Well, guess what? They were using default credentials, something as simple as admin. So next thing you know, I was printing my own custom badge. And there were several levels of failure here. Firstly, the kiosk mode was not properly configured. Secondly, the tablets were in the same network as the network printers, well, the badge printers. And thirdly, the web portal of the printers was using default credentials. Perhaps lastly, no one was attending the tablets. No one was there to stop me. Actually, one of the volunteers who was confused about the badge not looking like all the others handed it over to me without asking any questions. So this was a full exploitation chain of people, processes, and technology. And while I absolutely love web application hacking, you don't typically end up with souvenirs from web apps. Whereas with IoT, you sometimes may, like the custom badge, which you can see in the picture. Right, so a bit of context here. The idea behind this talk came about 7 years ago when I was a broke student. I used to live 2 minutes away from the beach, and I decided to order an inflatable kayak. It was $150, which was a lot of money for me back then. So I used it for a week and even lent it to some friends to use it. But one day, well, it started deflating. It was punctured, so I decided to send it back. And to be honest, I'm not gonna lie, I was a bit concerned that they will not accept it. It was obviously used, it still had sand in it, it was packaged horribly. But a few days later, I was pleasantly surprised to see that I got a refund. So this got my gears spinning. I thought, wow, I can really borrow things as long as I use their full price as a deposit. Actually, a few days later, I noticed that the kayak was reposted as pre-owned for cheaper. I did not do this, but in theory, one could have bought the item, returned it, and then buy it again from a different account for a bit of a discount. So I recently asked ChatGPT if this would be considered fraud. And by the way, don't take legal advice from ChatGPT. But here's what it said. This is not fraudulent if you are operating in the return policy, if the price drop is legitimate, so you're not actually getting involved in any sort of savvy shopping. However, it is potentially fraudulent or unethical if you are trying to game the system or force a price drop. So long story short, you should not abuse these return policies to get price drops. But you may be wondering now, where does IoT actually come into play here? Because we've been talking for 5 minutes and haven't touched upon IoT yet. Well, bear with me. Last year at DEF CON 32, Andrew Bellini delivered a brilliant beginner-friendly talk about hacking IoT devices. So I decided to start playing around with some hardware hacking. And this is when the idea became reality. Also, Michael Coppola had a great presentation at DEF CON 20 about backdooring stock firmware images for consumer routers. He even shared a tool he developed, the Router Post-Exploitation Framework, RPEF for short. Unfortunately, the last commit to that project was in 2013, so it would be great if someone could revive it. I also took a lot of inspiration from Matt Brown, who always puts some great hardware hacking content on YouTube. Also, Dennis Giza had some great talks at DEF CON in the past few years. One of my favorite ones being about hacking vacuum robots. Now, there are many great researchers in the IoT hacking space, and I'm sure you got the chance to meet some of them in these past few days. So, for this research, I formulated the following hypothesis. Retailers do not implement enough checks to prevent reselling backdoored devices. And to verify this, I defined a simple methodology. First, I'd have to identify devices with firmware which can't be overwritten. Then I should order those devices, modify their firmware, return them with the modified firmware, and wait for the devices to be resold as pre-owned, and of course, buy them again to ensure that the firmware modification was persistent. And the last step is actually the most important one here, as I do not want my backdoor to spread in the wild. And to do this, I created a simple web scraper which notified me on Discord every time a device from my list became available as pre-owned. This way, I could order it immediately, as soon as it was posted. Moreover, to reduce the risk of any negative impact if I failed to buy the device again, my backdoor was very, very simple and only worked as a proof of concept. So instead of implementing a full agent, which is communicating with my C2 server, I just created a mechanism whereby a simple request is being made to an EC2 instance owned by me, nothing more. So if the device is plugged in and connected to the internet, all it does is make a simple GET request to my HTTP server. Simple, right? So, well, the specific device used for this research is less important. However, I'll give you enough information to find similar devices yourselves. In theory, almost all OpenVRT-compatible routers can be used for this. And that is because people have actively installed the OpenVRT firmware on them, and the process is very well documented. So it is known that these devices support other firmware than the original one, right? Now, people have been looking at updating IoT firmware for ages. This may be either because they do not trust the vendors with their data, or just because they're not happy with the performance or the customization options for the devices. So, for instance, devices such as vacuum cleaning robots may expose sensitive information about the users. You could probably get an idea of the structure of the person's home, maybe get an idea of where they live. Now, I'm not sure if this is a feature or a bug, considering that we know that in 2018, the Strava fitness tracking app was used to expose hidden military bases in Afghanistan. In any case, there's several communities for people who want to create custom firmware for IoT devices. Now, you can join those communities and easily find hundreds, if not maybe thousands, of good candidates for this type of research. So for me, one of the most important aspects was that the devices must be cheap. I expected to break several of them during this research, so I didn't really want to break the bank through it. Moreover, based on my experience, suppliers of cheap IoT devices typically don't invest too much in security. Now, this may be a misconception, however, because cheap devices are more widely used and tested by users, whereas expensive devices may actually have less real-world security testing. In any case, I picked up several TP-Link routers, everyone's favorite IoT hacking beginner-friendly devices. And I ordered them from several reputable retailers, and the reason for this is that I was confident that I could override the firmware, but I expected each retailer to act differently. So I bought 15 devices from 5 different retailers, 3 from each. So I attempted a few different techniques for updating the firmware. First, I physically opened up one of the devices and pulled the firmware using SPI. And in theory, opening up the device would break the seal, preventing the device from being resold. And well, we'll see about that. With the firmware downloaded, I used binwalk to check out the file system. So I configured a service to run every 10 minutes and make a request to my IP address with a specific identifier. Moreover, I added a self-destruct in this service. So after 3,000 requests, the service was disabled and the script was deleted. So in theory, after about 21 days of running, the device would return to its initial state. And here you can actually see a few of my prior experiments, trying to change the TP-Link logo to my own. So with the modifications, I recreated the binary using make squash fs, and as you can see in the screenshot in the middle, or maybe you can't because the text is quite small, there was an initial discrepancy between the compression used for the original firmware and the modified one. The initial firmware was XZ compressed, whereas my one was zlib compressed. So for this reason, it is important to run make squash fs with the compression flag set to the desired method. This would prevent any sort of issues which may come further down the road when the firmware is not actually too close to the initial one. So now, in terms of writing the firmware, one can either use SPI to flash the memory or the web interface potentially to upload new firmware. So if you're lucky, you can go straight through the web interface, meaning that you could even conduct this attack remotely. On some devices, the web interface may check for various signatures, and in that case, SPI is most likely the way to go. And as you can see in the screenshot on the right, I was unable to upload the firmware via the web interface. Right here. Well, it's actually the left, but you're right. So I tried to write the firmware using SPI. And as my IoT hacking setup is rudimentary, to say the least, overwriting the firmware using SPI actually required very steady hands, which unfortunately I don't possess. And this was frustrating, and I really thought of pivoting to a different device. And this was all until I found a little workaround. TFTP, the Trivial File Transfer Protocol, which some devices use for recovery purposes. So where they query a TFTP server on a predefined local IP, looking for a specific firmware file. So my test seemed to work fine, and in the end, despite pressing and holding the reset button, only configurations were being removed, but my custom backdoored firmware remained. So now was the time to try and return these devices. And I mentioned that I changed my mind, I don't need them any longer, and that I was actually looking for different devices. And this was only 1 week after ordering. So a courier came up to pick up the hardware, and within another week, I received my money back. Great. No comments, no additional questions asked. Not even for the device which I opened up. So none of them have yet connected to my C2 IP up to this point. So it either means that the technical teams did not check the devices at all, or perhaps that they checked them offline without connecting them to the internet. Basically, they probably just plugged the devices in, the LEDs blinked, and they thought, okay, fair enough, they work. Right, so now what? To be honest, I was expecting to get some sort of callback from the devices in the retailer's network. And this would have proven some interesting impact, potentially getting a backdoor within the internal network of retailers. But this was not the case, unfortunately. With my scraper constantly running, I was waiting to see if the items were being resold. And at some point, I thought that they will just end up in a landfill. But a few days later, I got a notification. And another few days later, another one. So all tested retailers have reposted the devices as repackaged. And I tried to buy them all back. Well, out of the 15 devices, I was only able to buy 13 back. 2 of them were sold to someone else who was quicker than me. So you can see the resealed tape on the outer edges of the box. And you can probably also see that it says personalized security on the box. Well, of course it does. And yes, I got a call back from all 15 devices, even the 2 which were actively used and which I was unable to get. And almost a month later, I stopped getting callbacks from the 2 devices. And this is most likely thanks to the self-destruct script, which I set up. Actually, it's maybe more of a self-restore script because it actually brings the devices back to normal. Okay, so going back to the hypothesis that retailers did not implement enough checks to prevent reselling backdoor devices, I can strongly confirm that that is the case. Or at least it certainly was the case for the 5 retailers which I tested. So not only did they resell the devices, but they also did not properly check for the functionalities, which was obviously the case as I did not get any requests to my C2 server before they were resold. So even if they were to check the functionalities of the devices, they would have worked perfectly, and probably they would have been resold anyway. But let's talk about impact here. I only tested this on routers, but it can be done on almost any type of IoT devices. Instead of a simple script which sends a simple request to an IP address, a full-scale backdoor could be set up. Or maybe you could set up a botnet using each router as a proxy for your attacks, so you'd have access to several clean residential IP addresses for your attacks. At DEF CON 31, Dennis Giza talked about vacuum robots and even showed a proof of concept of how the camera can be used to transmit visual information. Now think about this, returning a vacuum cleaning robot after modifying the firmware to provide a live feed from the camera. You could actually see what's going on inside someone's house. And I say house here because regular people would be the ones typically buying repackaged devices. But who knows, maybe the facility manager at the office thought that they can save the company a bit of money by buying a repackaged vacuum robot. Great. Now you could potentially see inside some offices. Or even worse, the attacker could see that you haven't vacuumed in 5 weeks and decide to start a cleaning cycle for you out of pity. Well, surveillance cameras are a great example as well. Interesting case. We often see live feeds on Shodan from people's homes. The default configuration should be that the camera is not publicly accessible, right? But how about modifying the firmware to make the feed public regardless of this configuration? You can repeat this on pretty much any type of IoT device, washing machines, air conditioning units, you name it. But is this attack critical? Well, I honestly don't think so. And while most of this talk, I showed the shortcomings of retailers, they do have pretty well-funded fraud prevention teams. So it's unlikely that this attack could be done at scale in this context. So think about it this way. You just bought 500 devices, updated the firmware, and decided to return them. Well, it's unlikely that they will be as passive as they were with my 15 devices. Thus, it could be quite difficult to do this attack at scale. And I would argue that it is even more difficult to do this attack in a targeted manner. So I mean, how could you coerce someone into buying that specific device which you modified the firmware of? And while it may seem that this talk was mostly about bashing retailers, that's not the case. It's not their fault here. If you overwrite the original firmware while maintaining the expected functionalities, I guarantee you that no one will notice. I would even go even further to say that if we take retailers out of this completely, the severity of this attack vector increases. Think about it this way. You are a threat actor, and you open your own online store. You build it up over a few months, invest in advertising, and you sell products below market value at a price low enough that it's a great deal, but high enough that it doesn't raise any suspicions. You buy thousands of devices from a reputable vendor, modify the firmware, package them nicely, and sell them. And as you sell them, you have information about the buyers, like their names, their addresses, in some cases, the company name. So here, the attack could be done at scale. It could also be targeted. So you can only activate the backdoor if the device is being bought by someone specifically. So in terms of solutions, I think that the only sustainable solution here is going open source. And this may seem counterintuitive, to be honest, because devices which support open source firmware can have their firmware overwritten. But if it becomes common practice for devices to come blank and the users to write their own firmware on every device, it will become harder for such an attack vector to be successful. However, the obvious downside here is usability. IoT products would not be plug and play, and the technical level of the users would have to increase significantly. Actually, just wanted to check, how many of you here have proactively updated the firmware or on any of your IoT devices? Okay, maybe a bit over half. And, well, when I say proactively, I don't mean because you got a notification that you must update it, but just because you went to the vendor's site and thought, oh, look, there's a new version, I should install it. And think about it this way, we're all security people here, or most of us. How about the regular consumers? So no, there's no way right now to make people install their own firmware on blank IoT devices. But don't worry, there are still some technical solutions like locking the bootloader, signing the firmware, implementing secure boot, and potentially encrypting the firmware. But still, even with these in place, there are some fantastic researchers out here who found workarounds and ways to break most of these solutions. Some of them have even presented their research here at DEF CON these days. So besides technical solutions, one could consider things like tamper-evident seals, tamper-proof screws, one-way plastic clips, and of course, it goes without saying, even these are insufficient. Actually, people at the tamper-evident village at DEF CON have actively showed how to bypass these measures. And as you can probably tell, temporary solutions are not aligned with the open source approach. At the end of the day, there will always be a clash between open and closed source, where most IoT vendors will want to push their own firmware and prevent the possibility of overwriting it, while the open source community will typically look for workarounds and solutions because they do not trust these vendors. So, what can we actually do? If you want to avoid falling victim to this, I would suggest avoiding buying repackaged devices or even new ones from vendors or retailers which are not reputable. Well, this does not really protect you if you are targeted. As far back as 2010, it has been alleged that the NSA's Tailored Access Operation Unit intercepted shipping deliveries to plant backdoors in electronic devices ordered by their targets. So what can you do? Not buy IoT devices, live off the grid? No, that's not realistic for 90% of us, right? For non-technical people, I would say that not everything needs to be connected to the internet. Yes, IoT is about convenience, but now it's just becoming a bit too much. Also, perhaps stick to reputable vendors, as it's more likely that they are running mature security programs. And for the technical people in this room, I encourage you to engage in IoT bug bounty and vulnerability disclosure programs. And if you identify that firmware can be overwritten on devices, report it. And I'm aware that many programs specifically mention that these attacks, which require physical access, are out of scope. But I would argue, based on this little talk which I just delivered, that vulnerabilities requiring physical access should also be in scope. At the end of the day, the more the suppliers of IoT devices are made aware of this potential attack vector, the more likely they are to fix it in the future. Thank you. Cool, maybe we've got a minute or two for questions. Yes, please. So you're asking if buying directly from the manufacturer would be a better option? Yeah, for sure, without a doubt. That would prevent this specific attack vector. However, the devices may still be vulnerable, so who knows, maybe that people can resell them on. I think that the issue here is not necessarily the fact that retailers resell these devices, it's just that anyone can override the firmware on many of these. Cool, yes please.
More of a curiosity, so I saw you like extracting a part of the file system that thing. So two-part question. First, how did you get the binary firmware? And second, how did you determine the offset from which to start reading?
Yep, so that was pretty straightforward. So in this case, the firmware was completely unobfuscated, unencrypted, so just used binwalk. So it showed.
How did you get like the file?
Oh, yeah, just SPI. So literally reading it with SPI, but funnily enough, with TP-Link, they also post their firmware online, so it's publicly available.
And what did you like extracting the part from that file?
Yeah, so I only took the file system. That was the only part that actually interested me there. Yes, exactly. So I found the Squash FS file system there, took that out, and used it directly. Cool, there was another question. One more question, yeah? Yep. Right.
Didn't seem like malicious, but very, very clear that in between this model being returned and me purchasing it, it had not been altered in any way.
Yep. That's pretty cool. I promise it was not me. No, thank you guys. Thank you.